In this video we'll demonstrate a basic 3D modeling workflow by creating a pipe and its flanges using some common 3D modeling commands. Let's choose the modeling workspace, which will give us the appropriate tools for 3D modeling in the interface. Let's start with the lower flange of the model. To create this we'll use the box command. Its dimensions are 500 units in width by 500 units in length. Using the Tab key we'll switch the dynamic input field. The height of the box is 30 units. We now see in the Properties panel that a 3D solid is created. But at this point we can only see its edges. To change this we go to the Properties panel and change the visual style to modeling. This way the solid will display as rendered. What we see now is the top view of the 3D solid. If we want to change the view we use a Look From widget, which can be found in the top right corner of the workspace. By clicking on the arrows, we can change the current view. The box can be seen from the left, from the right, or from another orthogonal view. If you want to view the model in a way other than what Look From has to offer, you can use the mouse shortcuts. Hold down Shift and the mouse wheel button to rotate the view. Pan by holding down the mouse wheel button. Zoom in and out by scrolling up and down. We don't want the corners of the flange to be straight. To change that we use the DM fillet command. While using the DM fillet command, the hidden edges are visible. We'll now create the holes from the corner of the flange, but first let's look at the drawing. We see that the radius of the fillet is the same as the distance between the center of the holes and the edges of the corner. This means the hole and the filleted face are concentrical. We'll use this when we position the hole. To do this we create a cylinder that we'll use afterwards by using the subtract command to create the hole in the flange. When asked to select the center, we hover over the upper edge of the corner, and as the center O-snap mark appears, we just click on it. Enter the radius from the height of the cylinder. Given that the holes go through the entire flange, any value higher than 30 units is fine. Since the other three holes are identical, we can use the 3D array command, which creates a set of identical entities based on the input that we provide. First, we select the source entity, and choose rectangular. The number of rows is 2. The number of columns is 2, and the number of levels is 1. The vertical distance between the rows is 400 units, and the horizontal distance between the columns is the same. You'll see that BricsCAD creates the rows and columns at 400 units in the positive direction of the X and Y axis. So if the cylinders are created outside the existing flange, you can recreate the array using the negative value of -400 units. We'll also use the subtract command. For the object to subtract from, select the flange, then press Enter. Then for objects to subtract, select the 4 cylinders and press Enter to finish the subtract command. Now we'll create a circle which will be used as input for the DM push-pull command. To position it, make sure the snap tracking option is on, from the status bar. And to make tracking easier, we will disable dynamic UCS for now. Hover over one of the edges and from its middle point, move the mouse to the center of the flange. And you'll see that a tracking line is visible. Then do the same with the next edge and you'll see that another tracking line appears. Also, BricsCAD remembers the old tracking line and you can click to position the circle's center at the tracking line's intersection. Input 140 for the radius value. Now we're going to use the quad, which is useful in 3D modeling because it suggests suited commands based on the current selection. Hovering over the circle will detect its boundary and display it in green. If it doesn't turn green, just set the selection mode's variable to 15. Now you can see that in the quad, under the Modify tab, we have a push-pull command. Click on this and drag it downwards. Now that the lower flange is done, we'll create the pipe using the sweep command. To use a sweep command we need a profile to be swept, and a path to sweep along. Let's start with a profile. Given that the thickness of the pipe wall is 30, we create a concentric circle with the top edge of the hole in the middle and a radius of 170 units. Now if we hover over the surface between the hole and the circle, we see that the region is selectable, so this surface can be swept along a curve. To create the path we'll use the line command. The first line has a 500 units length and is parallel to the z-axis. Enable the orthogonal mode from the status bar, and move the mouse upwards. Next, continue drawing a line of 500 units parallel to the y-axis. Next, use the fillet command on the two lines with a radius of 250 units. We can now see our path is complete, but it's created from 3 different entities. We don't want this, because it means we'd have to use the sweep command 3 times. To avoid this we use the join command to form a single polyline that defines our path. Now that we have a profile and a path, we can perform the sweep command by selecting it from the quad. Now we only have to create the other flange, but since the two are identical, we can just copy the existing flange and then position it. To do this we'll use the manipulator tool. To activate the manipulator, you select the entire flange, and then choose it from the quad. And you'll see that the manipulator appears. With this we can move or rotate the flange, but for the moment we just want to copy it. So we'll press the Ctrl key while clicking on the manipulator axis and position a copy of the flange. We can then orient the flange using the manipulator to fit the orientation of the pipe. Now that we've oriented the new flange, it's time to accurately position it on the existing pipe. We'll use concentric 3D constraint and create the constraint between the pipe's surface and the central hole of the flange. Launch the DM concentric 3D command. Note that the second selected entity will be the one that changes the position to obey the constraint. To put the flange in contact with the existing pipe, we'll use the coincident 3D constraint. The previously created 3D constraints of the model are now displayed into the Parameters Manager panel. Now if we select all of the entities in the drawing, we'll see in the Properties panel that we have 3D solids. But we don't want that, we want the pipe and its flanges to be a single object. To do this we'll use the Union command. Selects the 3 solids and press Enter to merge them. Now, when we select the model, we can see that there's only one 3D solid. We can hide the solid and remove the lines and the circles that we've previously created. We can bring back the pipe using the Show Entities button. To finish our work on the 3D model, we'll use the DM Fillet command. If we select the edges and input the radius, we'll see that the 2 filleted faces are created. Similarly with the DM Chamfer command, we select the edges and input the offset. Now our model is complete and ready to be used in different assemblies. To create a 2D representation of the 3D model, we'll use the ViewBase command. We'll use the entire model default option, and the same default option for the layout. BricsCAD will change the space to paper on the selected layout, and we will position the views. BricsCAD can also create section views using the ViewSection command. Select a drawing view by clicking on it, and then define the section line by selecting 2 different points. We can also create detailed views by using the ViewDetail command. Click on the desired view, and then define the boundary and position the detail. Further information can be added to your drawing using the commands from the Annotate tab of the ribbon. You can create dimensions, multi-leaders, and add center lines for the holes, and more. And this concludes our demonstration of a 3D modeling workflow.